All right. So in this case, we are going to consider a typical exam question, still on our DC machines, and this is the part of the speed control. So this is August 2019 question paper that you're going to have, where we are given a 500-volt DC shunt motor has got an armature resistance of 0.25 when operating at full load. The armature takes 110 amps. So this is a condition that we do not know, like what's going to happen from this part. But now the question is, what resistance should be inserted in the armature circuit to obtain 25% speed reduction? So take note there, the speed is reduced. So meaning to say this is a speed control typical question. At the same time, we are given when the motor is developing 80% of the full load torque, meaning to say on the final condition, it is going to have 80% of the full load torque. All right. So we had a similar question like this one, but there's just one or two things to consider which are different. One, the calculating of the resistance that is connected. And where is it connected? It is connected in the armature circuit. All right. So let us consider this. We have got the first part, which is the original condition. So let us just consider our information, which is the data that you're given. So from the original, just gonna have our original condition. Then we also have the final condition on this side. All right. So there's a DC shunt, as we know, our circuit diagram. But if you have to consider this, you see that you do not even have the field resistance. So this is going to affect us, but just going to talk about this one. So this is the output power. Remember, there you've got the input power, the voltage, then the current, which is the load current, one, which as we are given there, this voltage. So you do not even have the load current there. All right, we do not have the load current. We have got only the voltage, which is 500 volts. So this is a 500 volt that you're given. The armature resistance, we also have got the armature resistance of 0.25, and the armature current, the armature takes 100 amps. So we are only given these, which is 110 amps. So that is the only information that you have, like, for now. Then on the final condition, still it is going to be a shunt one, which is a shunt motor. But they are saying the resistance should be inserted. Where is it inserted? In the armature. It is inserted in the armature circuit. The part of the armature is the one that is affected, not the shunt field. The field is not affected, meaning to say you are going to have your field as it is. Then the shunt, the part of the armature now, there is a resistor that is connected in the armature that we do not know. So we do not know this resistor, but it is connected to the what? To the armature. So this is our armature part, just something like this. All right, so this is just a sketch, guys. Your P out, as we know that you're going to have the generated EMF, this and that, but there is a resistor that is connected in series in the armature circuit. So the resistance of the armature is now affected. Yes, we are going to have its original value that was given as 0.25, but there is another resistance connected. So this will add, remember, in series. Okay, so V, which is 500, does not change. We do not have the part of the field. We do not have part of the load. We do not have even the armature current at the end. So this is what we are given. All right. So they are saying that we are going to obtain a 25% speed reduction, meaning to say the speed reduced by 25%. 25% speed reduction. The original speed we do not know. But on the final consideration, the speed, which is N2, is going to reduce by 25%. So that means it is going to be 100 minus 25% of what? Of the speed 1 that we are given before. So 100 minus 25, that is 75%, and 75% as a decimal, that's 0.75 of N1. So we are given a condition there that you're supposed to use. So N2 is equal to 0.75 of what? Of N1, because the speed reduced by 25%. All right. When the motor is developing 80% of, meaning to say, the torque that we had at full load, we do not know, it's just T1. But on the final consideration, it is developing 80% of the full load. 80% of the full, 80% of this full load, 80% of T1. So 80% of T1, it is the same thing as a decimal. If you divide by 100, that's 0.8 T1. So this is a relationship that we are going to use between the torque, T1 and T2, of the original and of the final. So with this information, the question is, we are supposed to calculate what resistance should be inserted in the armature, which is Rx. So this is what we have. We need to calculate Rx, the unknown resistance in series to the armature. So in this consideration, the speed control does not change the formulas. We want to get back to our formulas and talk about these formulas that we have. Remember, I said after this, write down the speed control formula, which is, from this formula, we have got this. I want us to be careful there. E1 over E2 is equal. The K there can cancel because it's the same. Then we are given this as flux 1, N1 over this is flux 2, N2. You can also consider this in terms of the field current. Remember, I talked about this formula in terms of field current 1, then this is N2, field current 2. We do not have anything to consider about the field. There's nothing given there. There's nothing. So assuming that the torque that we have is proportional to the speed, it follows that we are going to have this also given as N1 over N2 as the speed only. Meaning to say, we are considering the flux to be equal, the flux 1 to be equal to flux 2. This can cancel, N1 over N2. Current 1 and this one to be equal. There is no condition given, so it will end up as N1 over N2. Be careful with this one. So using this formula, the speed control, whether you want to calculate the resistance, the speed control formula has to be applied. You are going to calculate the speed, you are going to calculate the additional resistance. The additional resistance is connected somewhere. The moment that you think of calculating the generated EMF of the second circuit, this one, you're going to see that Rx is going to be involved. So the conditions are always bringing us back to the what? To the condition of our speed control, which is our main speed control formula. So the question is, on the main speed control formula, what is it that we need? We have now reduced this formula into this. What is it that we need? we need the generated EMF of the second circuit of the final circuit. Why are we in need of this generated EMF? Remember, the generated EMF is given by this formula. If you've forgotten this, you can even use your formula sheet. So I want you to see this. The generated EMF, which is the specific generated EMF, can be taken from this formula. Since this is a motor, we're going to subtract. So E is equal to, that is going to be V minus the armature current times the resistance of the armature circuit. So in the armature circuit, we are going to see that according to this final circuit, because this is the final circuit, so you're going to consider this as E2, armature current 2. This is the resistance of the armature current. This one. Having the armature current 2 in this case, you're going to see this part of the armature resistance, the resistance of the armature circuit. It consists of two things. The resistance, which is the one that you want to calculate, Rx, and the armature resistance originally that we are given. These are in series, so meaning to say you're going to add. So at the end, you're going to see that E2 is equal to V minus armature current 2 into, since there are two resistors in series, you are going to add these resistors, the unknown resistor that we need to calculate and the armature current that you're given. So you see that Rx, which is the one that we need to calculate, is going to be obtained from the generated EMF of that origin, of the final circuit. So you need this generated EMF. You're going to need this. So there is no way you are going to escape this speed control formula. No, you need this speed control formula. So on the speed control formula, our major focus or our main focus is to calculate E2. The E2 that we are going to calculate is the one that we are going to use to calculate Rx. So let's think of this. How can we calculate E2? What are we given? N1 and N2, there is a relationship that we are given about N1 and N2 in terms of the speed. Remember, we're given that N2 is equal to 0.75 N1 from the speed reduction. So it means these ones, we have them from this relationship. It means it's there. So are we having E1? We do not have E1. So you need to calculate E1 from the original circuit. Is it possible for us to obtain the generated EMF? All right. The generated EMF, remember, the formula is not going to change. The generated EMF is always equal to V minus armature current times the resistance of the armature circuit. Considering a motor, you're going to subtract. We have got the V, so meaning to say we can calculate this is going to be E1, A1, and so on. So we have got the voltage of the supply, which is 500 minus the armature current. We have got this one of the original circuit, which is 110, times the resistance of the armature circuit. There's only a single resistance of 0.25. So you're just going to consider that we do not have anything in series. So that is 0.25. So this was going to give us E1, which is going to, that was going to be 472.5 volts. All right. With E1, we are going to use it now to calculate, because now you have this, you have got E1. The only part that you do not have on this formula is E2. So you see the way that you're going to have these questions, it differs. Do as many questions as you can. All right, so substituting into this formula or making, we can even make E2 the subject if you want, or you can just substitute into the formula. Substituting into the formula is going to be the best according to this E1 that you're given. Okay, sorry for that. So this is E1 that you're already given, which is from the calculation, you have this one. So the relationship between N1 and N2 is from this relationship. So since we have a relationship to use, it will be best that you just substitute on your formula as it is. All right, let us just substitute as it is. So now we are going to calculate this E2. All right. So given E1 as 472.5, we can substitute this one. Let us just see. All right. Just hope we're going to win here. So this is 472.5 over E2, which is the one that you are to calculate. Remember, you want to calculate the circled part. N1, you are not given the speed, you are not given. But because there is a relationship of N2 related back to N1, you can just write your N1 just as N1. It will cancel with this N2 that you give. It would cancel with that part of N2. So you just write N1 as it is. Then the relationship of N2 states that it is equal to 0.75 of N1. So this part alone can make us to cancel this. Okay, so this is just same as we've got a 1 there. What we want is E2, so you can cross multiply to find this cross multiply. 0.75 is going to multiply the this part, and E2 is going to multiply 1. So that is the condition there. You are done. So that is E2 times 1 is going to be E2 is equal to the product of these two, 0.75 times 472.5. That was going to give us E2. All right, so which is 354. So this was going to be 354.375. So that's 375 volts. All right. So this E2, remember the purpose. Remember what I said here about E2. With the E2, you can calculate Rx, which is the unknown resistance connected in series to the armature. Because we have got the generated EMF of this part. We have got also the voltage. But are we having the armature current? That is the question now. Are we having the armature current? The armature resistance is there. This one is the one that you need to calculate, which is circuit. We do not have the armature current in this case of the second circuit. So if you consider this part, we do not have the armature current of the final circuit. So what are we going to use to calculate the armature current? Remember, we do not even have the load current. Forget about this field current. There's nothing to consider there. So I said, think of the relationship that you're given of the torque when it is of this nature. There is a relationship that you're given on the torque there. So it also follows that if you considered this condition, remember what I referred in terms of the E1 that we had. Also, this T can consider that T1 over T2 is going to be equal to what? The armature current, because remember it was supposed to be considering flux 1, armature current 1, then we have got flux 2, armature current 2. This, I said, is proportional. The torque is proportional to the speed. Considering that the flux is equal, the flux 1 is equal to flux 2. You can even cancel this part. Cancel this. Remember what you want to calculate. What you want to calculate is current 2. This is the one that you want. This one we do not have. Very true, we do not have T1. But there's a relationship that is given there. So it's going to be T1 over T2, which is T2 is what? 0.8 of T1. So this is equal to the armature current of the first circuit, which is the original circuit. We have got the armature current in this case, which is 110 already given. So this is 110 over what we want to calculate. So that is it. T1 and T1 can cancel. That's a 1 there. Cross multiply so that you can have the armature current 2. So that is armature current 2 is equal to 110 times 0.8. So 110 times 0.8, the product of this is going to give us armature current 2, which is 88 amps. All right, so this was going to be 88 amps. We have got this armature current now. So we can now substitute everything so that we can calculate our Rx. It's either you're going to make Rx the subject or you're going to just substitute. It's up to you. Now you can calculate your Rx, which is the unknown resistance. All right, the generated EMF2, we have it. So I'm just going to substitute here, which is 354,375 is equal to the supply voltage. Remember, it was 500 volts from each circuit is the same. This one does not change. So that is 500 minus the armature current 2. We calculated this. That is 88 into the sum of the two, the unknown resistance that you need to calculate, and the armature resistance, which is the one that you're given originally as 0.25. This is not changing. The only part is that there is a resistance connected to it in series. So it adds to that resistance. So the question is, we need to know what is the value of the resistance which was connected there in series. So it's now a matter of solving. I can transpose this since it has got a negative, transpose it to the left-hand side so that it can be a positive. So that's 88 into the bracket of Rx plus 0.25. Transpose 354, this side. That is going to be, already there's a 500 there, take note. So it's going to be 500 minus 354,375. So that is it. We can even divide by 88 both sides. Divide by 88 both sides to remove this. So you're going to be left with Rx plus 0.25, which is equal to the answer that you're going to have there, which is something like 1,655 and so on. So taking 0.25 to the right-hand side, it's a positive. So it is going to be a negative. So you subtract 0.25. All right, so that means our Rx is going to be 1,655 minus 0.25, which is 1,405 ohms. Just like that. So this is how you can attempt questions of calculating a non-resistance given a speed control question. So a speed control question, like I said before, it is a conditional question. You work with the conditions that you're given. This condition might differ with another one that you're going to have, another one that you're going to have, different conditions, but they are bringing us back to the formulas of our basic main speed control formula. So you need to revise along these typical exam questions so that you do understand how do they ask these questions on speed control and other questions also which are just on DC machines. So shall we have time of revising a typical exam questions like the whole question on DC machines so that we do understand how are they going to ask us these typical questions. You can see it was a 10-mark question. So these are the typical questions that you're going to have till we meet again.